Hello and welcome to today's Geminos Software webinar. My name is Samantha Lakin, host of today's webinar. I'm proud to be part of the Geminos team. We have an exciting discussion ahead of us today, but before we start, I just need to cover a couple of housekeeping points. Today's session is going to be recorded, and if you do miss any of it, or perhaps you want to share with colleagues, or maybe have a look at it at a later date, the on-demand recording will be available shortly after. We want this to be a conversational webinar, so if you have any questions, please send those over to us using the Q&A link, the tab at the bottom of the screen. You can also find the chat tab, which is used for more general discussion. Perhaps let us know what part of the world you're at, or what you're doing around causal AI in your organisation, or what role you play in your business. Feel free to participate and ask questions throughout the discussion. If we don't address your question live, then we can also look at it afterwards. So for today's conversation, we're going to be discussing the imperative of rethinking AI and real-world applications of causal AI. I'm joined by Stuart Frost, CEO of Geminos Software, and also Judith Hurwitz, the company's chief evangelist. So Judith, would you like to start?
Thank you, Sam, and hello, everyone. Let's start with our first discussion slide. So the most common approach to AI for many decades has been based on the idea of correlation. While correlation will show us the relationship between variables, it really does not help us explain the cause and effect of a problem. So in contrast, when you look at the goal of causal AI, it is the technique we use to model cause and effect chains in the business, so that we are really looking at the business problem instead of beginning with the data itself. So if we think about the problems that we are experiencing with traditional AI approaches, is it basically is based on a black box model, which cannot easily be explained from a business point of view. In addition, we can also see that biases can be introduced. For example, there may be references to race or gender that can become part of the data that really is inappropriate when we're trying to analyze a problem. So that by removing, once we see that this bias has been introduced, we can go into the model and into the data, remove that bias so that we have a clear understanding of the data that is so approaching it without explainability and without transparency really gives us a problem, because it just simply will take too long to get the type of quality of data that we're looking for. If we can move to the next slide. So when we are looking at causal AI, it's really important to understand one of the fundamental characteristics that is so important for organizations today, and that is it provides us a common language for both data scientists and subject matter experts to be able to collaborate. They're using the same language and the same way of approaching a causal situation. So in many situations, we are looking at some common questions that may be answered. For example, what is the actual outcome in the business that we're looking to solve? What are the levers that are most important that will help us change business so that we can be more successful? For example, why did a marketing campaign fail? We need to not just have suppositions and everyone pointing fingers at each other, but to really understand what the underlying cause is. what are the root causes for a specific outlier that has been approached suddenly in the organization. And if you do detect a problem, how can you change the way a problem is being addressed to change the outcome? So there are many specific problems that the hybrid team is trying to solve. And through a causal AI approach, it is possible for businesses to work across teams, whether it's data scientists, business experts, subject matter experts, to collaborate and work together to solve some really tough business problems that many of our organizations are experiencing right now. So, Stuart, let me turn the conversation over to you.
Well, thanks, Judith, and good day, everyone. So let me just give a quick introduction to the issues that Judith was talking about. And, if we draw a chart, for example, of ice cream sales versus drownings, we can see there's a very strong correlation between the two. And part of the challenge is the current state-of-the-art AI just doesn't understand that those two things don't cause each other. It sees a pattern in the data, and it would try to make predictions based on that. And the reality is, obviously, the situation is a little bit more complex. And the fact is, it's really driven by the weather in both cases. So there's an underlying cause of both. And obviously, we've also got to bring in things like time of year, location, maybe pricing, beach closures, whatever it is. As I said, the challenge is that AI today would not have an understanding of these causal relationships. So the core idea here, to begin with at least, is to model out the world using cause and effect chains. And we're actually finding that this is a really nice way for business analysts to model their problem, not having to get too involved in all the math of causal science, which is pretty complex. There's certainly, if you look at the academic papers out there, it is quite challenging sometimes to understand them. So a big part of what we're doing is to really use causation and use these causal models as that common language that Judith talked about a couple of slides ago, so that the business can express what they need in terms of these cause and effect chains, and then the data scientists can use that as a template. And we're finding this approach works really well. We're finding that business analysts can get up to speed quite quickly once they get over the idea that these are not flowcharts, they're actually causal models. We can also build knowledge models. I won't show any of those today, but we can have underlying knowledge models that help us to map out the data relationships and also then tie those into the causal models, so that we can actually populate the causal models with data through that mechanism. So let's take a step back and talk about the kind of state-of-the-art AI. And as Judith said, one of the big challenges is that we're really just using black box algorithms. These can be very monolithic, very complex. And while we can use certain techniques like SHAP analysis and so on to look back and see what features are driving the algorithm to a certain extent, it's pretty opaque. It's very difficult to explain, and certainly extremely difficult to explain in ways that make sense to the business users. So we've got this kind of fundamental problem of challenges with explainability, bias, etc. And there is a school of thought that says, well, just throw more data in there. But the problem is that that simply doesn't work. What we're doing is just making some of those issues of bias, etc., worse rather than better. So throwing more data at the problem just isn't the answer. So we believe that causal AI is definitely the next big step. And what we've done is created a comprehensive low-code causal AI platform with a goal really of making it a lot more accessible and practical and directed at common business problems. So the kinds of things that Judith mentioned in terms of, I've got an outcome variable. How do I change it? How do I optimize it? If it drifts over time or changes over time, how do I fix that? What are the levers on the business that I have to improve things? So far, we've focused on a lot of kind of smart manufacturing, supply chain, defense use cases. But it really is applicable to most industries and use cases. We're finding a very, very broad applicability of these techniques. The platform is all based on established open source, primarily Node-RED, which came out of IBM, but it's now supported by a separate company. Very, very widely used low-code platform, and a great fit for us. So what we've done is built Causal and knowledge modeling into Node-RED. And it's created a really comprehensive end-to-end platform. You go all the way from business analysts modeling out the cause effect chains, as I mentioned, modeling the data, and then actually generating the application. And the next phase of development for us as part of the platform is to actually build the causal models into the running application and monitor them as they're running. So this is a really important aspect of it, because sometimes in business things go wrong or they don't run as we expect. So what we're doing is really building the platform out so you can monitor those on an ongoing basis. And then the platform will actually say, using Causal AI, will say, look, something's drifting or something's not working as we expected in the model. Here are the levers that you have. So really directing it towards business problems and using the underpinning of causal science to make all that possible and give it a solid foundation. Oh, I've got to move slides in slightly wrong over there somehow. I'm sorry. So let's take a look at the Causal platform. As I said, it's based on Node-RED. We've built in established libraries from people like Microsoft and Amazon. They're the primary ones that we're using at the moment. And I'll come back to that in a moment. The PyY collaboration between Microsoft and Amazon is in our view, a very solid foundation for this. And as I said, our goal really is to use the math in those libraries. They're all based on Perl's work, to leverage that math and those established libraries and bring it, all that power to solving business problems. So that's very much our focus. And Microsoft told us recently they've had over 1 million downloads of the DoY library, which speaks volumes, I think, for what's going on with Causal AI. As I said, going all the way through the model here, we believe that causal modeling gives you a common language between business and data science. You can validate and refine those models to remove things like bias. Far more explainable. You can walk through with a business user and explain what the causal model means, etc. Pretty easily. We're not finding that's a big barrier. We can then hydrate all those models with data. We can do causal discovery against that data, see if we've missed anything. We can also really focus in on what data do we have, what's missing, what else do we need to really build a meaningful solution. So in some ways, kind of turning the AI development process on its head. We think it's very important to capture subject matter expertise up front and then check that against the data, rather than kind of, the traditional approach of let's gather all the data we can find, let's clean it all up. That can take months in itself. And we don't really know what's important. We don't know what might be a source of bias. So this is a bit of a different approach to that, and we think it's extremely powerful. We can then build, as I said, the solution directly on that. We can greatly reduce things like bias, much more explainable, and the transparency of the whole process is much better. So we think overall that's a much better way of creating these kind of solutions. What I'd like to do here is just talk about a typical solution that we've been working on the last few months. This one is involved with production of metals and electrolysis. So there's a kind of whole fundamentally industrial process behind this. Electrolysis is obviously used very widely, all kinds of metals, etc. And the carbon anodes are a key component, typically made of carbon, but there could be a few other materials in there. And one of the important aspects there is that we want to minimize the resistivity and so control the resistivity of those anodes as we're producing them, because that reduces the cost of the process further down and gives us better quality materials ultimately. So very important aspect of it. So, let's look at the process. This is subject matter expertise, right? So we mix up different coke sizes. We put a certain amount of energy in, we do it at a certain temperature, it's then cooled, what happens there, what variables can we look at? It's all vibrated and compacted to form a raw anode, and then they're baked. And all aspects of this can have a different impact on the final resistivity, which is, as I mentioned, is what we're trying to really control here. So using the Geminos platform, what we can do is, given the model, we can actually look at the resistivity of a set of anodes that we've produced over time, and we want to shift that. So the first problem is optimization. So how do we minimize the resistivity on average? So moving from the yellow, the pre, to the purple post. So what is it in all those factors, all those variables that I showed on the previous slide that really would help us to move that mean, the distribution? And also sometimes we might see a shift over time, as we mentioned, right? How do we move it back? What levers do we have? So you can see in this time series here, at some point in 2015 on this chart, it moved. Why? What caused that? And what can we do to move it back? So that's a classic problem, and obviously in all kinds of different industries, different use cases, etc. These are pretty common problems. And a big part of the platform, the way we've developed it, is to directly address these kind of problems and help you apply the causal science that underpins it all, so that you can actually understand what's going on and make the appropriate changes as you go. So the first step we really generally do in this is to take a model first approach. So let's model out the process. So you can see we've got all the different variables that we think we might need. So this is purely done on subject matter expertise at this point. Obviously, you can look at the data. It's not a hard and fast rule. It's iterative. Like most development processes, you have to, look at the data, look at the subject matter expertise. But generally speaking, we prefer to start out drawing the model, understanding the business problem, understanding the critical outputs, and really thinking carefully about what inputs what we have, and also what are important. So that's really quite important. The other thing that we're doing is starting to build templates for standard business processes so that we can publish those in the platform, and you can start to build more Lego-like. And obviously that's something that customers are doing as well. They're building their own templates. They're publishing those across the organization so that we've got standard kind of pieces, if you like, standard Lego pieces to build from. We're also looking increasingly at common data sources like social media, financial information, ESG information, you name it, and looking to build causal models across those that we can then publish, and working with some partners on that as well. So there's a lot of activity on building up a base of existing templates and causal models with the attendant knowledge models, so that you have something to start with. What we can then do once we've built that model is, and this is all built into the tool, do the basics of causal analysis. And we can do this even without the data initially. So what we're seeing here is the energy mixer being the kind of primary driver of this, the treatment variable that we could change in this particular scenario. We know there's what we call a front door path to resistivity there, but also some backdoor paths that would introduce bias. They're correlations. If we go up the wrong way up a causal path, then what we're doing is introducing a correlation relationship as opposed to a causal relationship. So we want to eliminate those. We want to block those. And the tool will tell you which variables to condition on so that you can actually block those paths. What that's doing immediately is reducing the set of data that we might actually need, or and telling us which ones we need very high quality data for, etc. So that's a useful start point. We also might discover, though, that we simply haven't instrumented the whole process at this point. So what we might have to do is simplify the model a little bit. We might have some effectively unobserved variables. And we can still keep those in the model, but we might actually, we need to reconsider things perhaps based on that. and really understand as well from a causal point of view, do we need to actually get that unobserved data at the moment in order to get a good result? So this kind of balancing act of, okay, I've had to simplify my model now. Is it good enough? Is it actually going to give me a meaningful business result? And obviously that's very important. Once we've done that though, and I can show the simplified model here, what we can then do is understand, based on some modeling out here, and again, we're building this out in the tools to help you, we actually provide the business with a roadmap for future instrumentation of the process. So if we see that there's a couple of variables that are currently unobserved, we can say, look, these are going to be important going forwards. You might want to invest in these first, and we can give a sense of what the ROI would be for that investment. Are we going to get a much better outcome once we've actually made that instrumentation, added that data source? So again, really thinking about the business outcome. How do we drive that? How do we get better results over time? And providing the business with a clear investment roadmap where it's appropriate to say, you're going to need more data here, sorry, to get a good result. But in the meantime, maybe we can drive a good enough result and make some progress. And I think that's also very important as well. So the other thing then is I mentioned PyY, and that's the logo for it. So this has resulted from a collaboration between Microsoft Research and Amazon Science. Microsoft really kicked this off with the DY libraries, which, as I mentioned, they've had over 1 million downloads, which is pretty stunning when you think about it, because it's a pretty complex Python library. You've got to be pretty into causal AI to make sense of that library. So the fact that there's over 1 million people out there that have downloaded it and at least at the level of playing around with it, we don't know how far they've gone with it. But that speaks volumes, I think, for both the challenge of the current state of the art of AI and people looking for better solutions, and also the sheer level of interest in causal AI, which is obviously fantastic from our point of view as one of the very few startups in this space. So by applying the PyY library, what we can start to do is initial steps like this, which shows us the kind of relative causal strengths and direction, whether it's positive, negative, etc., of each causal link. So here we're starting to think about, okay, what is really driving the anode resistivity? What are my really big levers? What are the things I don't have to worry about too much? And of course, again, this drives the kind of data that we need to think about. If something really isn't all that causal, maybe we don't have to spend too much time cleaning that data up. We might still use it in the model. We might still have it in there as a driver, but maybe we don't have to spend months cleaning that source up, and we can get by. But where another variable might be very significant, relatively speaking, we want to invest there. So it's really helping us to avoid that situation where we can spend months with a significant team just cleaning up all the data that we've ever gathered, which can be an exercise in a bit of futility, in my humble opinion. Obviously, these are guidelines, you've got to use it carefully, but we do think there's a lot of advantage in this kind of approach. And then going back to, optimizing the resistivity. So again, these are screenshots straight from the tool. So what we're doing here is checking out the different variables. We can move the value, for example, of the temperature of the preheater by 20 degrees. What does that do to resistivity? And this can all be modeled out in the tool once we've got the data. And this is really using some of the latest stuff that Amazon added to the PyY libraries. They've used this kind of root cause analysis and so on quite extensively in their own infrastructure. So it's been, as we understand, quite well tested and used out, and can be applied to many different situations. So we're finding it's very applicable to lots of different use cases. So it's pretty fundamental, right? If you can understand what really drives the outcome and what's going to move it, you understand the levers on the business on a much more granular level, a much more effective level. So we can, I think for me, this is one of the first real obvious business benefits of using this approach, we can really start to say, how do I change that outcome? What's driving it? What levers do I have? What interventions? And that's one of the big powers of causal AI, right? Is if I'd done this differently, what would happen? Help me out here. Help me understand this. So very, very powerful approach. And again, if there's a shift in the distribution, so I'm running the system, gathering the data from it, and I notice that the resistivity has changed over time, what caused it? So the nice thing is here, the tool can actually help you understand what is driving that, what's the main root cause, what are the various factors driving it. So in this situation, what we're doing is just a bit of a kind of scenario where perhaps the cooler has a fault, can't reach the right temperatures, can't get that fixed maybe for a few weeks, the engineer can't get out, or the parts aren't available. Okay, great. That's a problem in our business process. What do we do to correct that in the meantime? So what are the other variables in our model that we can, the levers on the business to shift that distribution back? Might cost us a bit more in the meantime, maybe, but at least we can continue to get a decent business outcome. So that's, again, build it into the tool. You can actually assess, okay, if I now increase the heater temperature or vibrate it more or compress it more, whatever it is, how can I compensate for that short-term problem? And again, we're finding this is applicable to lots of different use cases. I mean, you can imagine this in all kinds of intelligence, defense use cases, different business scenarios, not just industrial processes like this one, but all kinds of business processes, marketing, sales. An interesting project kind of just kicking off for sales intelligence. So, if I'm qualifying accounts and I've got good performers, bad performers, etc., how do I improve performance overall? What is good practice? What is bad practice? The other big aspect that we're working on here as well next, which is just coming out in the tool, we've been reviewing the internal releases, is on outlier analysis. And again, this is based a lot on the work that Amazon's done. So if I've got an outlier, like in that sales intelligence use case, I might have a particular salesperson that is performing better than the rest. How do I shift the mean towards that outlier? What is really causing that outlier performance? And of course, it might not be positive. It might be a negative outcome. So if I've got negative outliers, what do I do? How do I fix that? Is it a behavioral thing, or do I need to make a change with the staff or whatever? Help me out. What is causing that? So that's another very big step. And you'll be able to see that in the tool within the next couple of weeks. So that's coming up very quickly now. So hopefully you're getting the sense that, where we're going with this is that very much targeting kind of styles of use cases, and then helping you to apply all the causal science that underpins it all in very practical ways, without necessarily having to go right to the libraries and write Python code and understand all the math. We're doing that, a lot of that work for you. Now, of course, you can, in the tool, go into the libraries if you wish. We're not preventing that. You can, if you have the expertise, you can certainly do it. But the goal here is to really make it a lot more accessible. I think there's a tremendous promise in the approach of causal AI, but it is challenging with the state of the art. If you go straight to those libraries, it's tough and can take quite a long time to get up to speed. We're really looking to change that whole dynamic and make it much easier to apply to typical business problems. So that's the presentation today. I see there's been a few questions in there in the thread, so we'll start to go through a few of those. Feel free to reach out to Samantha if you want to get more information. You can also use these QR codes to book a demo or a meeting, go straight to some of the staff's Calendly link. And if you just want to learn more about it, go to the website, or again, this QR code will help you learn more about causality. So Judith, I think you're going to kind of moderate
Okay.
questions for
Yeah,
me.
so let's some of these may have been answered already in your talk, but let me start with some of these. So Ian asks, when you say causal science, do you have a general approach? Neiman, Rubin, do calculus from Pearl?
So we're very big proponents of Pearl's approach, definitely. So definitely more in the kind of do calculus and the modeling camp, very much so, right? That's, you know, I myself and some of the employees here go back 30 years working together. And the company that we all worked on in that time was a modeling tool company. So that's kind of our background and the way we think about problems. And you know, the libraries, etc., that we're leveraging here are all based on Pearl's work. So that's generally the approach. Now, that's not exclusive. You can use the libraries to do the Rubin type approach. But to my mind, you know, model the business problem, providing that common language between the business analysts and the data scientists, that's actually a significant breakthrough in itself. Which I think then is the precursor to getting all the benefits of the underpinning causal science and the math, etc.
And Ian also mentions Causal as a resource.
That's a new one. So yeah. Thanks, Ian. I will look at that. It's obviously a field that is just exploding, right? I mean, Pearl tweets out a list of causal related papers every week, and there's 40, 50 papers every week. So it is a fire hose. So I don't think anyone can claim to be up to speed on everything. So yeah, thanks for pointing that out. I'll check it out. I certainly haven't heard of that one so far.
Another question is, seems like it assumes causal graphs, so no structural learning.
Well, we're building that in. That's a big part. You mean like causal discovery from the data? Yeah, so there's a lot of activity on that front, and we're very involved in that. Microsoft is building that out in the PyWhite library, Microsoft and Amazon working together on that as well. So it's definitely a part of the overall process. As I mentioned, it's not just a simple, model it first and then look at the data. It's iterative. We go back and forth. What we're really working on is to get that iterative loop built into the platform so that you can really get the best of the libraries. We found that just using those kind of raw, the level of sophistication in both the user and so on is quite high, let's say, requirement. It's a pretty high hurdle. But we're finding actually on most projects, we can start with a model first, then do causal discovery. Have we missed something? And be more targeted that way. The causal discovery libraries we're finding work a lot better if you give them a meaningful kind of common sense start point based on subject matter expertise. If you just go ahead and run those on the data raw, you can get some pretty confusing results at times, and it does take quite a level of expertise. That's an area, frankly, of the technology that is just moving so quickly. So we're very involved in that. We're also working with a few different groups on different approaches to that as well to augment it. And we're doing some work as well. We're even looking at things like ChatGPT, etc. Can we tease out if we direct it in the right way? Obviously, what we don't want to do is get the current problem of it looks like it makes sense, but it's kind of gibberish. We're exploring whether we can drive it, ask causal questions, and train it in the right way. And of course, that's a field as well, GPT, that's accelerating rapidly and will get better and better. So multiple approaches to that. But at the moment, with the state of the art, our recommendation is capture the subject matter expertise first, use that as a start point, and then start using the libraries.
Excellent. Another question. Business templates sounds really helpful. Can you validate the graphs on multiple data sets across many use cases? Then users could have more confidence in the structure.
Yeah, that's a great point, actually. And obviously, early days, we're building up the customer base quite rapidly, thankfully. So it's great. But yeah, so we are looking at ways to do that. And one of the big things is that we're looking to build a community around the platform. And that's going to be, people who have expertise in causality. So a customer could go on and say, hey, can someone help me with this model to help me validate it, etc. Also, people will be able to publish these templates and over time build a customer base for that. So the idea is to, within this community, to actually build a marketplace, both for expertise, but also for these templates. So yeah, that's very much a work in progress. We can't claim to have, fully tested in all kinds of scenarios, these templates, but it's definitely part of the goal. And if you are interested in that, the main person at Geminos that's driving that is Dan Kirsch. So Dan will please feel free to reach out. You can get to him through Samantha, obviously. So if you are interested in being a part of that community, please let us know. And we're just kicking off the building of that, etc.
Okay, another question. Do you have tools to help get input from subject matter experts? Collaborative causal mapping tools? If so, is that map representative in a way that makes it useful in a bottoms-up discovery from data, i.e. nodes and edges are objects rather than a bunch of pixels?
Yeah, right. Well, that's really the point of the community that I just mentioned, so that we could use the platform as a communication mechanism. And that can be either on a public basis to the community or private in the background. It's up to the customer. So yeah, absolutely. That's a big part of what we're trying to drive there, so that you could, share models, share data sets, have people apply their expertise to it. And, given the sheer number of universities that are now offering causal courses, we think there's going to be a lot of kind of, graduate students, PhD candidates, etc., that instead of flipping burgers to make some money, maybe they can engage in the marketplace and help people actually get the most out of causal AI and help build that community. So we think that's perhaps a way to help there. But that's another really encouraging aspect of this, right? We're seeing university courses pop up all over the world, new ones all the time. So obviously there's a lot of people coming into the market with at least some level of expertise.
Okay, another question, actually, two people wanting to know the same answer. What underlying causality theories are you using to enrich the models and graphical model here?
Yeah. So as I mentioned earlier, we're very much, proponents of Pearl's approach. So we are using and generally following the work that Microsoft Research is doing on building out the PyY library. So it's very much based on Pearl's work. And as they, improve those libraries and work on them, we'll be very quick to adopt the latest technology, etc. We're also looking at some other libraries, as I showed on the slide there, excuse me, hiccups. We're looking at McKinsey's libraries. There's a whole bunch of new people coming up. The library that Uber created and some people at Toyota have been working on is also extremely popular. So we're looking to build that in. So as the field generally, moves very quickly and libraries get richer and richer, you can really view Geminos as that kind of open platform that will be very quick to adopt the latest approaches. We're also, frankly, looking to make that interface as open as we can, so that customers that maybe have their own libraries or want to adopt a different one could, with the right expertise, obviously, or help from us, could build those libraries in. So we are looking to open that interface up. It's not quite there yet, but we're building that out as a pretty open interface to accelerate our own development.
Okay.
Yeah.
So next question, how long does it take to get up and running using this platform for a subject matter expert to capture their knowledge into the solution?
We're actually finding that's remarkably quick. And I think that's fundamentally because, cause and effect is how we think as humans, right? It's not alien to us. It's not a completely new way of thinking. As toddlers, if we learn cause and effect by building stacks of bricks and knocking them down. If we knock the top one off, right, they don't all fall down. Or if we knock one off from the bottom and we do it really quickly, maybe the stack doesn't fall completely. So human brains work in terms of cause and effect. It's common sense fundamentally. Obviously, it gets more complex than that once you start to bring in the probabilities and causal effects, cause and effect strengths, etc. But the tool handles a lot of that for you, and obviously that's also where the data scientists would pick that up. So from a subject matter expert perspective, we're not finding that's a very high bar. So it's been very encouraging that people can pick that up pretty quickly. The challenge more is on the data science side. You certainly have to be open-minded about adopting causal AI and get the benefits of it. But, 1 million people downloading the library, that's very encouraging, because most of those are data scientists out there that are interested in this and willing to put the effort in. So we're finding that there's a lot of people out there that are looking to adopt this technology.
Great. And then another question, can it be integrated with Python programs via APIs?
Absolutely. It's all Python-based. The libraries are all Python-based. And it's pretty easy in Node-RED to integrate Python, etc. It's one of the beauties of basing it on the established Node-RED platform. There are literally thousands of nodes that you can drag and drop onto the models. You can go straight from the Geminos models, causal and knowledge models to create a complete application at whatever level you want. It's any cloud, it's all containerized, etc. And yes, you can use Python as part of that. And obviously all the underpinning like PyWide libraries are all Python. So yeah, we're pretty Python centric, but not exclusively. You can use different languages if you wish, but you can bring in R libraries or whatever you want. It's a very open environment. So it's one big advantage of adopting that established open source capability.
So I got a complex question here, but maybe we can answer it briefly and then get back to you. Reproducing and shifting the distribution back to the previous one does not mean you will get the same generative process. So it does not guarantee the correct discovery of causal pathways. It could be just one of many equivalency networks. How do you resolve this problem?
Okay, so what I was really referring to there is that imagine an industrial process like the one that we talked about. It's not so much recreating exactly the same distribution. Obviously, that might be impossible, right? We might not have sufficient causal levers to pull on to get exactly back. The idea there is that it helps the business understand if something's going wrong, how to at least get not necessarily the same distribution, but a better distribution than otherwise would be the case with the current broken cooler or whatever it is. So it's more about, I'm running a business process or an industrial process. It's not working as I would like it to. The distribution has shifted. How do I nudge it back? Because of course, you're absolutely right? The causal paths are different. The distribution of the data is different. I might not be able to fully compensate. So that's really what we're driving at there, though. In the meantime, what do I do? And ultimately, what's the cost of that, right? Why would I not do that in the first place? Well, it might be that it's really expensive or really difficult or something I'd only want to do for a short time because it creates extra wear on the equipment or whatever it could be, right? There's all kinds of scenarios. So that's really where we're coming from that perspective, if that answers the question.
Another question, pricing on your website mentions free for research. Does it have to be the university research or can it be open source, non-commercial research?
So we want to really encourage usage of the platform for those kind of scenarios. So certainly, obviously we need to be careful about that. But if you come to us, talk to us about it, if it's clearly research and non-commercial, definitely we want to encourage that. So in general, the answer will be yes. But obviously, I'm sure you'll understand that we're going to tread a little carefully there and make sure that the license is appropriately signed, etc., to make sure it's pure research. But yeah, fundamentally, that's why we're doing that. We really want to encourage broad usage of causal AI, and we want to be the ubiquitous platform on all fronts that makes that happen. So yeah, please approach Sam about that, and we'll have a dialogue with you on that front.
So another question, if the causal model built using your previous data, don't you still have the same data quality bias issues?
Well, so the point there is that, if in building a causal model, what you're avoiding is just throwing all that data into some algorithm, which is very, lacking in transparency and explainability. We're breaking the problem down really into a series of smaller, more explainable algorithms. So each kind of effect node in the model has its own little function. Some of those could be quite simple. There might just be linear regressions. There might even be on off, right? Something happened, I've got to turn on. Simple as that. Or it could be a very complex, deep learning based model or something like that. But in general, what they are is relatively small regressions or curve fitting. So curve fitting doesn't go away in causal AI. What we're doing is breaking it down into those individual kind of effects. Okay, what caused me to happen? What are the precursors? What data caused me at this point? What does that cause me to do? What's the outcome? What are the unobserved variables? What's the noise, etc.? Let's understand all of that. So what we've immediately done is broken it down into a series of small steps. And as we talked about earlier, what we're also doing is really understanding the potential ways that we might have introduced bias and how to block those, what variables to condition on in order to block those potential sources of bias. Obviously, ultimately, we're still based on, subject to the quality of data, but it's not the quality of every data point. It's the ones that are important causally and the ones that are important to block potential sources of bias. So we've immediately kind of started to reduce the number of data points that we need to worry about.
Excellent. So another question. What are the stages to building a causal AI solution? Model, build, deploy. How do you hydrate with data?
Right. Okay. Sure. So, in general, and obviously these are all iterative processes, right? So it's not as simple as, it's not a waterfall approach by any means. So certainly don't want to give that impression. But model the problem, capture the subject matter expertise. If there are appropriate existing causal models that we can base it on, great, let's bring those in. The tool allows you to break things down both horizontally and vertically to reduce the complexity of a given model that you're looking at. So if you're talking about a really complex process, then you can break it down into various steps. You can also build the underpinning knowledge model, which is entities, relationships, attributes, and create the links to the causal model so you understand, what variables you're talking about it in the causal model. So that's all built into the tool. You can then bring in data into that knowledge model, so you can hydrate the model, and then you can actually run all the causal libraries against that. You can run the causal libraries against the model even before you've got data, just do the kind of backdoor and front door analysis and understand the potential sources of bias, etc. So you don't need to even hydrate the model with it at that point. But then once you've hydrated it, you can run the full power of all the Pyrite libraries, etc., do all the outlier analysis and root cause analysis that we talked about. And then you can actually start developing an application directly from that in the platform. So you can actually start to create all the hooks into the data sources. There's existing nodes for just about any data source you can imagine. If you want to create a temporary data source, you can use pretty much any database in the platform that's already built in. If you want a social media feed or whatever, that's already available to you. So there's thousands of nodes there to help build out the application. And then what we're fleshing out in the tool at the moment is then building the kind of causal understanding into the running application. So kind of going that next step, not just creating the app, but actually monitoring it as it's running, and helping you understand the levers that you have when things go wrong or you want to make improvements over time.
Okay, I think we have time for 2 more questions.
Cool.
The first one, which probably could take about an hour, but I'll give you a minute to answer. How do you compare your solution with Causal Lens AI and MasterCard APT?
So I'm not aware of the MasterCard one, so they've got their own, huh? That's new. We'll have to look at that. We've Causal Lens is a good product based on what we've seen so far. I've never tried it, but we've seen a couple of the webinars and everything. They're mostly focused on financial services, a little bit of healthcare, so a little bit of different industry focus. And I think generally a bit more kind of consulting oriented. We do consulting, we do training, but we're an out-and-out real product company. That's our main focus. We think that Causal Lens is a bit more on the consulting side. I think price points, etc., are quite a bit lower, but fundamentally we propose the same kind of approach. My view, frankly, is that this is an enormous opportunity for causal AI broadly. It needs multiple players. I want us all to succeed. I don't see this as a kind of zero-sum game where we're, Causal Lens are our enemy in any way. We're on the same path to promote the benefits of causal AI and to grow the market, and there's plenty of opportunity out there for us all to succeed. So I think that's all good. So I'm certainly not going to get into any kind of specific pros and cons. I think they've got a good product. They're having some success, so are we, and we're on parallel paths here and friendly.
Okay, so I've got a question here. I'm wondering how helpful this is when we have incomplete science. We can link the bacteria on the skin to the skin health, but this could be correlative, or the bacteria affects the skin directly, a causal, or the state of the skin affects bacteria that can live upon it, which is causal. And we also have circular causal link, when bacterial change the environment, skin, so that skin can live in the environment that also changes.
Cool, that's an interesting one. Yeah, I mean, look, I think, and I think Pearl would agree with this, right? I mean, in many ways, the reason Pearl went down this path was to really help people apply good scientific practices to these kind of problems. So what you're doing, you're setting hypotheses, you're gathering the data to test that hypothesis, you're building the model that you think is effective, and then you can test that and use the science underpinning it to explore different scenarios and so on. So really for me, it's, kind of forget at the moment the idea of building an actual AI solution for this. The scientific aspect of it and exploration of it, considered from a causal perspective, is extremely powerful. And, often what we're doing when we're working with customers is setting causal hypotheses, building a model that we think makes sense. Of course, it's never perfect. You're modeling the world, right? That's the basis of every scientific hypothesis, let's face it, right? You're creating a model of the world that you then want to test. And the idea then is it good enough? Is it close enough to the real world to actually get good results? And are there things that we discover over time that change our understanding? And that's the nature of scientific discovery. And in many ways, I kind of view the platform as a mechanism for doing that. And that's kind of what we're doing between business users and data scientists, right? We're going back and forwards. We're setting hypotheses. Is this what we really meant? Is this really going to solve our business problem? It's the same for the kind of, bacterial scenario that you just described. But that's a fascinating use case that we'd obviously love to talk to you further about, whoever it was that asked that one.
So last question, I promise, Stuart.
That's okay. I'm enjoying this. It's great.
How does causal AI differ from Stephen Grossberg's work on adaptive Is that well?
Wow, I'd have to get back to you on that one. So let me not just wing that one, because it's been a while since I looked at his work. So yeah, let me. I'll give you a written answer to that one separately, if that's okay.
So Duncan, send a specific email, and Stuart will write you a 10-page paper.
Yeah, maybe a couple of paragraphs, but yes. Well, no, what we can do is have a chat about it, right? But let me, refresh my memory on that work first. It's been a little while.
All right, so I'm going to turn it back to Samantha to close out our session.
Well, thank you very much, Judith and Stuart. And also for everybody that took part today. We really hope you found it interesting, looking and reading all the questions and the ones that we haven't had a chance to answer. Obviously, clearly, it's a very interesting topic. So as Stuart mentioned earlier, we've got various different ways of getting in contact with us afterwards. The QR codes on the screen, if you'd like to book a demo, I'd like to find out more information, then please do. We're more than happy to share our thoughts with you and show you the product. And also there's going to be a link at the end of this. It's just some feedback really for us. So if there's anything in particular you want to see on the next webinar that we've got coming up, please write that down. And if you're interested in finding any more about us, there's also our website to visit. So thank you all for attending, and enjoy the rest of your day.